later, because as it turns out, it's much easier to think of the phases as either advanced or retarded by some number between either plus 90 or minus 90 degrees. That takes care of the full 180 that you need, okay? Because you could say that, you know, I want to advance it by more than 180, but then I would say, no, let me have it lag by less than 180. So 180 degrees is all you're ever going to need, and expressing that range of 180 degrees as plus or minus 90 is more intuitive. But 3 pi over 2 is not incorrect. It's exactly right. Euler would be very happy with that. But if I then gave you crazy numbers like, you know, 80 pi over 2, you'd say, oh, what's he doing to me? Why isn't he just putting it in the range plus or minus pi over 2? But mathematically, it would be perfectly fine to go to 3 pi over 2. Okay. So, everybody follow this so far? So, in the step of finding the total impedance, since it's add and subtract, we're going to use impedance values from this left column, but then later on when we have formulas in which we need to multiply something by the impedance, we're going to use the right-hand column and just pull that out, and that will allow us to do all the calculations. Now, presumably at first the calculations are going to seem strange and bizarre, and by the time I get to the last one, you're not only going to be hungry for lunch, you're going to be bored because they're repetitive, and then you're ready for the final. Okay? So, here we go.
We're using this for the camera.
The first circuit that we have is an it's an RC circuit. And so in the RC circuit, you found out how to turn around? Okay, cool.
How do you turn it around?
So, in the RC circuit, we have how many circuit elements? 2, R and a C. Yes, there's a question. No, I can't make the screen brighter. I can momentarily make the room darker.
Yeah.
Then discuss the picture on the screen, but then for the purpose of videos, and also seeing the chalkboard, I'll make it brighter. Okay? So, this circuit is a series circuit with an R in series with a C. And so, if these were 2 resistors, how would I get the total resistance of 2 resistors in series? I'd add them up. These are 2 impedances. In order to get the total impedance of this circuit, I'm going to add them up. A plus IB, C e to the I phi. Which one?
A plus IB.
A plus IB. So, my Z total, what's the A plus IB format for the impedance of a resistor? R. What's the A plus IB format for the impedance of an inductor?
Oh, yeah.
Capacitor. Oh, okay. Minus I over omega C. What I wrote for an inductor was correct. The only thing is the circuit doesn't have one of those, and therefore it wasn't relevant. So it was right but irrelevant. Okay? Everybody good so far? Ta-da! That's the answer in A plus IB format. What we would like to do is we would like to write this in C e to the I phi format, because C is the magnitude of every complex number, and phi is the phase of any complex number. So we write that as magnitude, like absolute value signs, of Z total, and we'll get a formula. And now, every quantity has a phase. If I wrote phi equals, that would be kind of a crazy thing to write. Because there's a phase to Z, there's a phase to I, there's a phase to the voltage on the power supply, there's a phase to the voltage on the resistor, there's a phase to the voltage on the capacitor. There's gazillion phases. If I just write phi equals, I'll be writing kind of a crazy thing. I need to write the phase of a particular thing, and so I will write the phase of Z total. Okay? And then I need to get some numbers. So, what's the magnitude of Z total?
R squared plus radical of R squared.
square root r squared plus 1 over omega c squared. Oh, look! There are numbers in the problem. So, we can put them in. I think I brought a hand calculator, so I can put them in also. So as long as the laptop bag has not pushed the on button so long that the calculator is dead,
I squared is -1.
which it has. What's the resistance? Given in the problem as 120 squared. But hold on, I need to know 1 over omega c. Let me pull the calculator forward for a moment. So what's 1 over omega c? Well, what's omega? We're told we have 120 ohms. We're told we have 3 × 10⁻⁹ picofarads, which is 3 nanofarads. We're told we have a peak voltage from the power supply of 10 volts, and we're told we have a frequency of 500 kilohertz. What's omega?
2 pi f.
2 pi f. So, omega is 2 pi 500 kilo hertz, and C is 3 × 10⁻⁹ farads. So, what's 1 over omega c? How much? Somebody got a number? My calculator's dead, I'm afraid. 106. 106. 106 what? Ohms. All impedances are in ohms. Okay? So, when I go back to finish out the magnitude of the total impedance calculation, what I'm going to have is 120 squared plus 106 squared, which gives me what for the total impedance? I'll write the number on the left. 106 squared plus 120 squared. $160? So the total impedance of this thing is 160 ohms. So now, yes?
Sorry, what was that last thing you did? You were calculating the impedance of the capacitor.
Yeah?
What was that last number? 3 times 10 to the...
Oh, that's the capacitance.
Oh, that's the capacitor.
That's C.
Oh, okay.
Yeah. That one there is C. So it's 1 over omega. Omega is 2 pi f. 2 pi f. C. Okay? All right. So, how am I going to get the phase of this thing?
106.
Yes.
I heard a can of
1 over positive or negative? Minus 106. Because we just got done calculating that 1 over omega c is 106. I could write out all the letters, but that's not useful at this point. I'd rather put in the number because I've evaluated it. This is minus 106 divided by 120, which is how much? How much?
Negative 41.45.
Minus 41 degrees.
Right.
Is that what I heard? Okay. That's the phase. You can write it in radians, you can write it in degrees. Presumably your grader is going to be smart enough to understand what you meant. Particularly if you label it. If you put a little circle on it that it's degrees, then they should interpret it as degrees. Okay? Does everybody follow that? We now have a complete and thorough understanding of the impedance of this circuit. Okay, the impedance of this circuit, if we choose to write it in CE to the I5 format, is that this thing equals 160 ohms e to the, Euler forgive me, minus I 41 degrees. Now why did I ask Euler to forgive me? You can't put degrees in there. In this formula, you can only put in radians. It's one of the reasons that mathematicians love radians so much. Every formula is amenable to radians. Not every formula is amenable to degrees. This formula, degrees don't really belong there. So you can multiply that by pi over 180, but I'm going to leave it like that because all of us know what we mean. Is that agreed? And I think people, they get this sort of comfort zone that develops around degrees. So everybody understands what that means. That's the Z. All right. So I think that we've finished parts A and B. Oh, wait, we moved on to the next problem somehow.
My bad.
Yes.
Quick question. Do we have to revert to radians, or can we just leave that degrees?
I wouldn't care. If I'm doing a real circuit, I prefer degrees. But Euler wouldn't like what I've done with that last e to the I pi. Because, in fact, a mathematician would correctly say that result doesn't really have a meaning. Because powers aren't really angles. So, but you know what I mean. Okay? So far, so good? Now that we've got the total impedance, how would we get the total current? This would be what we once called Ohm's second law. Remember that? Ohm's 3 laws. So what's I?
V over Z.
V over R for resistors, V over Z in AC circuit theory. So I total is what V over what Z? V total over Z total. It means I need to do what?
Find V.
Divide. Okay? In order to divide, which format of the impedance from the previous calculation is the most reasonable to use?
Second one, right?
Yeah, the CE to the I5 format, because that's much more amenable to division. So the denominator here is going to be 160 ohms e to the Euler forgive me. Okay? Everybody with me? Now, V total is the V of the power supply. So it has a magnitude, V power supply, and what does the problem tell us, if you scroll back down a little bit, was the voltage of the power supply?
10 volts.
Yeah, now what kind of a voltage was that? Peak. Now I have a question for you. When I write I equals V over Z, am I talking about peak values or RMS values?